Hello, my name is Benjamin Clark, and this is my screencast on strain gauges. So what is a strain gauge? A strain gauge is a device that is used to measure the strain in an object. There are a couple different types of strain gauges. The one I'll be talking about today are resistance strain gauges. This type of strain gauge consists of an insulated piece of metallic foil that is adhered to the surface of an object that a strain measurement is wished to be taken from. So how does it work? A force is applied to an object. As a force is applied to an object, it undergoes deformation. This deformation is proportional to the force being exerted. As you can see in the figure on the left, a force is applied and its original length is changed by the value delta L. The elongation, or delta L, over its original length is called the strain. A strain gauge may be attached to the object, which causes the strain gauge to deform as the part deforms. This deformation changes the electrical resistance through the strain gauge, which may be measured. The relationship between the change in resistance in the strain gauge and the force can be found by calibrating the system by applying known forces to the object and measuring the change in resistance. A data acquisition system, or DAS, is used to obtain and store and later interpret information that is gathered in this way. In this case, a strain gauge is used as the sensor. Many other different types of sensors can be used, and strain gauges, in fact, come in many different shapes and sizes, and they can all be used as the sensor in a DAS system. A signal conditioner supplies the sensor with a steady voltage, also called an excitation voltage, and amplifies the signal returning from the sensor, taking readings at a set frequency. The set frequency varies greatly, from a couple hertz to several thousand hertz. Some basic filtering may occur at this stage at the signal conditioner. The data is then stored in a computer or other data logging device, and when convenient, the data is then processed and the useful information extracted. There are a couple important limitations to be aware of in strain gauges. Strain gauges are extremely sensitive to electromagnetic fields, and strain gauges in some cases can be affected by electromagnetic waves. They kind of act like antennae. This may foul up data if there's a lot of electrical noise around your sensors. There are a few ways that you can avoid this. One of the ways is shielding the wire that goes between your data acquisition system and your sensor. Also, reducing other forms of electromagnetic interference is suggested. They're extremely sensitive to vibration, and this may cause your data to be difficult to interpret. Changing the sampling frequency can, in some cases, help with this. Also coupled with filtering, that can reduce the effects of vibration on your measurements. Strain gauges are also sensitive to heat. As a part is heated up, it may change its size. This can be compensated for while using a Wheatstone bridge. Come back next time for another explanation on how strain gauges can be applied to help gather information to solve engineering problems. Thanks.